All right. If you've ever been offshore, gripping the helm for hours, you know the feeling. The sea just constantly wants to shove you off course.
Absolutely.
And maintaining that perfect heading, well, it takes serious focus.
Yeah.
Older autopilots, sometimes they just feel like they're constantly fighting back, right? Always overcorrecting.
That constant battle, that sort of push and pull between the pilot and the sea state. Yeah, that's exactly what the newer marine electronics are trying to fix.
Okay.
So for our deep dive today, we're digging into the source material on Raymarine Autopilot technology. We're really looking beyond just basic steering. They actually call it intelligent navigation.
Intelligent navigation. I like that. So let's get into the nuts and bolts then. Our mission here is to figure out how this tech is really different from those older sort of mechanical pilots that just hunt back and forth across the course line.
Right. The ones that feel a bit crude sometimes.
Exactly. And we need to see how it plugs into the whole system, the Axiom displays, radar, sonar. And maybe most importantly, why getting it professionally calibrated. The sources mention expertise, like Concord Marine Electronics in Fort Lauderdale, why that's so critical, like the make or break factor.
And the big picture takeaway, really, is that this tight integration, this ecosystem approach, it leads to, well, noticeably more comfort, genuinely better safety, and frankly, some pretty surprising fuel efficiency gains.
Okay, efficiency gains. We'll definitely circle back to that.
Yeah, for vessels from, small runabouts right up to super yachts. It's about smarter sailing, smarter cruising.
So let's start with that core difference. We're moving past those reactive systems. What's the key concept behind Raymarine? The term that keeps popping up is adaptive intelligence.
Yeah, adaptive intelligence. What's really interesting is that the system isn't just using some generic off-the-shelf algorithm that, works okay for a typical 40-footer.
Yeah.
It means the autopilot is actually capable of learning the unique handling characteristics of your specific boat.
Learning? How so?
It figures out your hull shape, how the weight is distributed, the thrust from your engines or sails, how the rudder actually responds in different waves, different speeds. It builds a profile.
So it's not just holding a compass heading, it's creating like a dynamic behavioral model of the vessel, and this happens over time.
Exactly, over time and in real time. It's constantly interpreting data from all the connected sensors, GPS for position and speed, those sophisticated 9-axis compasses for heading and orientation, wind instruments if it's a sailboat.
All feeding into this brain, basically.
Nope, precisely. And it uses that to anticipate the course corrections needed before the boat significantly deviates. It's not waiting for the boat to wander off course by a degree or two and then yanking the wheel back, which causes that kind of jerky, uncomfortable ride.
Okay, so it makes these smaller, smoother adjustments proactively.
Much smoother, much more efficient adjustments. And that proactive steering makes a huge difference, especially in rougher seas.
I bet. Now, I also saw a specific feature mentioned, AutoTrim. Is that tied into this learning, or is it separate?
Oh, AutoTrim is definitely part of the adaptive process. It's specifically focused on keeping the boat balanced, maintaining proper trim, even when conditions or the load changes. Think about fuel burning off over a long trip or shifting winds affecting heel on a sailboat.
Okay, so it adjusts for those subtle changes automatically.
Yeah, it makes these really precise, smooth trim adjustments. And that directly means fewer times the crew has to jump in and tweak things manually. It also reduces the workload on the steering pump itself.
Less wear and tear, and definitely less fatigue for whoever's on watch. That makes sense. So if the system's making fewer, smarter rudder movements, avoiding that constant sawing back and forth, how does that connect to efficiency? You mentioned fuel savings.
That's the direct link. Think about it. Every unnecessary rudder movement makes the hydraulic pump work, drawing power. And it also disrupts the boat's momentum, creating drag. By minimizing how often, how much the rudder moves, the system keeps the boat on a much straighter, cleaner path.
Less zigzagging, basically.
Exactly. And that straighter path, that optimized route, directly cuts down the energy wasted just on steering. Over a long passage, that adds up very quickly to real fuel savings.
Okay, that connection is clear now. Reduced rudder action equals reduced drag equals fuel saved. But this intelligence, no matter how smart, can only work well if it knows what else is going on, right? Which brings us to the whole system integration idea.
Absolutely crucial. An autopilot in isolation is, well, limited. Its real strength comes from communication. Raymarine designs its whole suite: radar, sonar, chart plotters, displays to talk to each other constantly. They share information using NMEA 2000 connectivity.
NMEA 2000, can you just quickly define that for someone who might not be familiar?
Sure. Think of NMEA 2000, or N2K as it's often called, as the the central nervous system for modern boats. It's a high-speed data network, the industry standard, that lets all your different electronics, GPS, depth sounder, engine gauges, autopilot, AIS, wind sensors, all share data seamlessly and reliably.
Got it. Like USB for boats, but more robust.
Kind of, yeah. A reliable backbone. Without that shared data, the intelligent autopilot is essentially flying blind to what the other systems know.
And the main place you see and interact with all this data, the command center, is often a Raymarine Axiom display. Let's look at that interface. How much control does the captain actually have from that Axiom screen? Is it just basic on-off or full control?
It's remarkably seamless, really full control. The Axiom's where you plan your route, tapping the screen to drop waypoints. Then you just engage the autopilot and it takes over, calculating the best path to follow that route.
So it's more than just hitting go to waypoint.
Oh, much more. You get full graphical autopilot controls right on the chart. You can initiate complex maneuvers like an auto tack function for sailboats. You can easily edit waypoints while underway, change autopilot modes, all without needing a separate control head, though you can have those too.
And you see feedback right there.
Exactly. All the critical info like your current heading, the target heading, rudder angle, cross-track errors, it's all overlaid right on the chart display. This integration is huge for safety because you have complete situational awareness in one place. Less looking away, especially at night or in bad weather.
Yeah, minimizing stress during tricky navigation sounds like a major benefit.
It really is. And because all the sensors are sharing data across that NMEA 2000 network, the autopilot can make even smarter, proactive adjustments based on the whole picture, not just the compass setting alone.
Okay, moving from the tech itself to getting it on your boat. Once you decide, okay, I want this smarter autopilot, how do you pick the right one? It's not one size fits all, I assume.
Definitely not. The selection depends entirely on the boat, its size, its displacement, the type of steering system it has, hydraulic, mechanical, linear drive, and what you plan to do with it.
Can you give us a quick rundown of the main Raymarine EV models and who they're for?
Sure. So the EV100 is generally for smaller boats, power or sail, often with wheel or tiller pilots. Simpler systems, lower power draw.
Okay.
Then you step up to the EV150. This is aimed at mid-size power boats, typically with hydraulic steering. It uses those more advanced 9-axis sensors for better control.
Got it. Mid-size power.
The EV200 is a real workhorse, designed for larger sailboats and motor yachts, often with more complex steering setups. It really leans into that wind and compass adaptive steering for offshore work.
Right, the serious cruising boats.
Exactly. And then there's the EV400. This is the heavy-duty option. For large yachts, maybe commercial vessels, needing high-power output for big hydraulic rams, often with multiple steering stations integrated.
Okay, so a clear progression based on size and need. But even if you pick the perfect model, this leads us to what seems like a really critical point in the sources, installation and calibration. Why is professional setup so vital? Why can't you just, bolt it in and go?
This is where a lot of DIY attempts fall short, unfortunately. The absolute heart of the system is that EV sensor core, the compass brain, essentially.
Yeah.
Its placement is critical.
Why? Magnetic interference.
Precisely. If you mount it too close to a big chunk of metal, an engine block, a large speaker magnet, even heavy gauge DC power cables, you introduce magnetic deviation. The compass gets skewed.
And what does that skewed compass reading mean when you're actually trying to steer a course?
It means the boat wanders. Simple as that. Instead of holding the heading like it should, rock solid, the boat might constantly drift off maybe 2, 3, even 5 degrees before the pilot realizes and corrects.
So it's constantly fighting a phantom error.
Exactly. The autopilot is steering based on bad information. It completely negates the whole point of the adaptive intelligence. It ends up hunting back and forth, burns extra fuel, and just feels lazy and unreliable. You lose all the benefits.
Okay, so how do the pros, like the NMEA certified techs at a place like Concord Marine Electronics, make sure it works flawlessly? What happens during that calibration, especially the sea trial part?
Well, their process is really meticulous. First, they verify the sensor core mounting, making sure it's in the best possible spot, magnetically clean. Then they ensure the whole network is talking correctly, the Axiom displays, the drive unit, everything integrated via NMEA 2000.
Right, the baseline setup.
But the magic really happens during the sea trial calibration. They take the boat out, run it at different speeds in different directions, maybe do some turns. They're actively teaching the autopilot the specific nuances of that boat's steering geometry.
So they're fine-tuning it live.
Exactly. They dial in the precise rudder limits, how fast it should turn, the response sensitivity, all done at sea. They're essentially tuning the system to perfectly compensate for that specific vessel's unique momentum and any tiny lag in its steering system, making sure it holds the course perfectly without wandering, regardless of interference.
That sounds like the absolute key difference between just having an autopilot installed and having one that actually performs to its potential.
It really is.
And we have some hard evidence for this in the source material, right? The case study with the 70-foot Princess yacht. What were the results there?
Yeah, that was a great example. They upgraded to the Raymarine EV200 system after the full installation, the hydraulic interface setup, and that crucial sea trial calibration by certified techs. The results were, well, pretty stunning. They documented a confirmed 30% improvement in fuel efficiency during long passages compared to the previous system or hand steering.
Wow, 30%. That's huge. That's not a minor tweak. That directly proves the value of getting that specialized calibration done right. It pays for itself pretty quickly in fuel alone on a boat that size.
Absolutely. And it wasn't just the fuel savings. The case study also highlighted how much it reduced the crew's workload.
Right, less fatigued.
Less fatigue, more confidence. The owner felt much more comfortable during night passages and offshore legs because the steering was so consistent and accurate. It meant more restful watch rotations. The focus shifted from constantly correcting the course to just maintaining overall situational awareness.
Okay, speaking of situational awareness, let's broaden that out. If the autopilot's handling the steering so precisely, how does linking it with other key systems like Raymarine radar, they mentioned in the Quantum 2, how does that boost safety?
Integrating radar takes it to another level. It creates a truly proactive collision assessment and avoidance system. The radar, using MARPA tracking,
Which stands for?
Manual Radar Plotting Aid, although it's largely automatic now. It identifies and tracks other moving vessels, calculates their course and speed, and displays that threat assessment right on your Axiom chart plotter screen.
So you see potential collisions developing visually?
Exactly. You see the closest point of approach, time to closest point, all calculated. This allows the captain to see a dangerous situation developing well in advance and to make a timely decision. You can then instruct the autopilot to make a smooth, efficient course change to avoid the conflict. It's invaluable in fog, heavy rain, or busy shipping lanes.
Yeah, proactive avoidance instead of last-minute reactions. Makes sense. And for boats maybe not needing a full Axiom network, you mentioned the Element series earlier. How does that fit in?
Right, the Element displays. They offer a really powerful but maybe more streamlined option, particularly good for smaller or mid-sized boats. They pack in excellent sonar, like their hypervision, and have robust built-in GPS.
And they still talk to the autopilot.
Oh, yes. They integrate seamlessly with the EV autopilots via NMEA 2000. So you get that intuitive route tracking, waypoints, and autopilot control combined with great sonar views all on one screen without necessarily needing the complexity or cost of a full multi-display Axiom setup. It makes that precision navigation accessible.
Good to know there are options depending on the boat's scale. Okay, so we've really covered the ground here. The adaptive learning that makes Raymarine distinct, the seamless control through Axiom or Element displays, the absolute necessity of that professional sea trial calibration.
Absolutely key.
And the payoff, right? That incredible 30% fuel saving seen in the case study, plus the enhanced safety through radar integration.
Yeah, it paints a pretty clear picture of what modern systems can do when properly set up.
So as we wrap up this deep dive, what's the final thought you want to leave our listeners with, something to mull over?
Well, think about how much these advanced Raymarine systems rely on integrated data. The radar, the sonar, the GPS, the compass, the autopilot itself, they're all sharing information constantly over that NMEA 2000 network. Their performance, their safety benefits, their efficiency gains. It all hinges on that flawless communication and accurate data. So the question to ponder is this. Given that deep reliance on interconnected systems, just how much of your navigation system's total potential safety, potential efficiency, is actually left untapped, locked away, if you miss just one critical piece of that puzzle? Like skipping that meticulous expert at sea calibration. What's the real cost of cutting that corner in today's marine tech landscape?
That's a powerful point to consider, the difference between having the gear and actually unlocking its full capability. Excellent food for thought. Thanks for walking us through all that.
My pleasure.
And we'll catch you on